Welcome to the group exhibit Hydrogen, Fuel Cells and Batteries at the Hanover Fair 2017. We are here at the Technical Forum and my name is Muriel Burkas. Please have a seat, have some drinks, help yourself, and I hope you enjoy the upcoming presentation regarding design to service of Micro-CHP systems. Please welcome on stage with me the head of division Fuel Cell from Next Energy, Dr.Alexander Dyck.
Thank you. Thank you for listening. For design to service of Micro-CHP systems. I'm not Tobias Thomsen in case I have to jump in for him to present. I will do my best to bring it to the next 10 to 15 minutes and give you a short introduction first of Next Energy, where we have three major divisions. And we are in the division Fuel Cells, where CHP systems were covered. We come from the northwest of Germany in Oldenburg, where the earth is real flat, and you see where the maintenance guy is coming, and hopefully he has the right parts with you to maintenance your CHP unit, and hopefully he don't make mistakes. In this division Fuel Cell, where I'm the head of, we have the CHP systems. We look for mobility, where also maintenance and all the stuff and quality issues are an important issues. Also the characterization issues, even in conjunction with the CHP systems, and latest on the materials that also will be reflected inside the material inside the CHP systems to have a stable and a long runtime of the CHP systems. The project D2 Service is a European funded project from the FCHU, started 1.5 years ago. The midterm report is quite in the next weeks. That has to be with 7 different partners from 5 different countries. With Bozal, where also one colleague is there from the project team. With Ballard as a fuel cell supplier, Solid Power as a fuel cell supplier, 2 research parties, Next Energy and ZBT. Energy Partner as a system integrator, and British Gas also as a system integrator from Italy and UK. We are calling it the project, and the main target is our motivation to save time in the maintenance, in case time is normally also money. And nobody has to want to shift or to stay one day at home to make a maintenance of a CHP system. So normally it should be an hour or maybe 1.5, and then you may become late to work, but don't spend a full day. And it's an important thing what you have to do during a maintenance. It's a replacement of the things like the desulfurization unit and the water treatment, and it's technically complex and it's a time-consuming process. If you must close some fittings, and you must look afterwards that it's again gas tight and waterproof, and the parts you use are quite expensive, so you have to come to standardized parts inside the systems. And it's also an effort or a benefit if the maintenance guy has not a couple of different cartridges inside his hopefully small vehicle, and he's hopefully your parts for your CHP units also in his cupboard. And it's important that the people are trained somehow. You know, if you come with a maintenance guy, he also has maybe some suppliers he likes most, in case he know where the parts are. And we have tried to give guidance also by maybe interviews or videos where the exchange of materials is more easy. It's important that service intervals at the moment are quite shortage, and there has to be an expanded somehow for the right. Normally I want to see my maintenance person annually or even more. The time in a machine, it stands for the time of maintenance, and like a power plant that has to shut down for 5 years, for a week or something, for maintenance process or service process, at this time you will not have hot water or something like that. So maintenance time should not be a week, otherwise you will not have a satisfaction factor at home. Or even if you have a rental, even your rent, the persons that will influence will be not happy about that. The cost of maintenance is also strongly reflected by the time it's used for this. Using standardized components, it's with just a few tools and not a full toolbox with specialized tools is quite helpful. Otherwise, you will come with 3 large suitcases to your home. So it should be with normal stuff and things that the infrastructure could be set it up, and easy after 1 hour he could leave without dirt. Also important is that no error comes up during that. So after its improvement of gas tight, it should also be on again and not fail after 1 hour or 1 second or something like that. So the maintenance guy is just away and you have to call and wait for 1 week again. Maybe also not helpful. For that, it's important that the design of such a thing is so unique that this one tube or one connector just fit for one position, or the positions are even so connected that it's easy and unique that they could be connected. So this could be avoided somehow, and it seems obvious it doesn't fit. It will not be gas tight. So it's easier to check up and that you can see that that it should be the right connection in this way. If you look on a CHP unit and you look on the return temperature of the CHP, from this graph it's obvious. If you have a low return temperature, your CHP unit get more and more efficient. And that's the point where that has to be discussed for which flat the high efficiencies that are reported could be adaptable, and how you can make positions inside your CHP systems where you can make failures by the installations even from the CHP unit or during maintenance. One thing is that the insulation of your gas pipes are not effective in this way. So insulation in the hot parts of the system should be avoided, otherwise your room where the heating system is stored is hot, but your living room is cold. So it should be an advantage to have the insulation in the right place. In this case, it's quite good insulated. It's in case it's in our laboratory where we have the time and also the place to make a good insulation inside the installation. Where you need different temperatures is quite reasonable. So if you only have a floor heating, you have only really low return temperatures, and your CHP unit could be very efficient. If you have an overall building with the floor heating and the domestic hot water, it's 35 degrees, and even the overall efficiency is a little bit lower. But in case you could not bring all the energy from hot or warm energy inside the storage system. It gets even worse for old buildings where you have a radiator heating, or where you have an old domestic hot water system where you need return temperatures from 55 degrees C, and the efficiency will be lowered. So CHP systems will be also adapted also by different technologies at this case. Just a sketch I like to bring the point on the hot water storage, and where you can make a mistake by just making the installation on the wrong place. And if you can make it, if you put it on only a low volume of hot water storage, and have a position in the high level, you can make a best position for a CHP system, and you can also make a wrong or a mistake in taking it in the low level, where you don't store in an effective way the heat coming from the CHP system. And the additional heating system will switch on much more or earlier, and will be not effective as the CHP unit itself. It's very important to have also realistic scenarios inside this added value to test the CHP unit like we do at Next Energy in our laboratories. This is very helpful in case you can even speed up your test time and make even annual tests in a 6-month period. I think I will not go in 10 minutes through all the slides in case how we do it, but we can show them in the later process on that. And we could make the evaluation of the performance annual, and also other efficiency operation things that we call a standard, and we can make reproduce a year. But normally you compare your energy demand from this year with last year and the year before, but you don't have the same winter. And so the results are strongly influenced by this your seasonal adaptation. And if you take in mind that your family will change and also your energy demand changes over the years, it's not comparable. And that's what we could do in our installations to get reliable results of your CHP units, and you see improvements by making changes, technical changes inside your installation, and we could repeat the measurement. So we calculate this with some typical working days, work days, Sundays, and in wintertime, summertime, and mid-term, there's a temperature definition. Maybe you can sketch up in the video afterward and look at my video again. On the other hand, you have how many days you have of working days or Sundays, and it's cloudy or with a fine weather condition. And you could have even 15 different climate zones in Germany where you can locate energy demand and calculate it for your area the right energy demand. This makes it helpful and bring a new standardization issue where you have some load profiles to evaluate your CHP unit. And where you have here the heat demand and tap water demand, and here is the electrical demand over the full day. This will be reflected in the guideline VDE 4655, also mentioned for a multi-family house where you can see which energy demand it is. How we can make the test time, you bring some days together, don't read the schedule, you can look in this guideline and where you can see how much days you can combine to make the shortage time of the test bench itself. So it's easy to make your test time in the lab, that is always expensive also, quite short. We have, in the D2 service project, we have 2 CHP units, one PEM type and one SOFC type, where we have a buffer storage where the energy was stored with use profiles on the tap water demand, and the electrical energy will be stored to the grid. This is the picture from the 2 units installed inside Next Energy Labs. It looks like an ugly place. It's a nice and lightful lab environment where the installation is quite easy, and errors are avoided by conditions for the maintenance guys. In case they have good light conditions, look normally in where your CHP unit is. It's a dark place. It's quite tiny conditions. At this place, we have always good conditions to make maintenance and to avoid failures from the basics. As a summary and conclusion, to get even maybe some questions, is that the system integration is an important factor to have an efficient operation of a CHP unit. Otherwise, you have a failure and it may be in the wrong position and you lose efficiency in your site. It's a precise planning of the installation. If you could have a precise planning, you could avoid mistakes from the basics. Next Energy is applicable or available to make some test profiles and make tests with CHP units to shorten test times and get reproducible results. That's very cost effective, and we could also make training for the trainers or for installers to have maintenance in good working conditions to get practice and to be a benefit for the CHP manufacturers. At the final end, the manual with the recommendations to have installations, in the worst case even the heat transfer unit is maybe damaged. This should be also easily reinstalled, but this is the topic for the next lecture. At this point, if you have any further questions, you can contact Tobias Thomsen. He's maybe the expert for the project and the project leader at our part. Otherwise, I'm happy to get your the audience and attention, and I thank you for your time and have a nice day.
Thank you very much. So, are there any questions right now? Okay, so how is it at the moment? You said you didn't really try it or test it in real, like in bigger projects or examples, or
we have
only in the lab so far?
There are installations in the field where we have also data, or the manufacturers has data, and yes, they are reliable or exactly comparable to our results. Okay. Not exactly, in case you and me will be different.
Yeah,
anyway.
But you also said training is important. Would you also provide trainings, or do you hand out manuals, or?
It will be part of the project that manuals for the installation guys with the units that are part of the project will help to make the maintenance more effective, and have even, you will not send the person from the maintenance or from the manufacturer from Italy to Oldenburg every time. Otherwise, the travel costs will overcome after some maintenance the benefit of the. So there must be some persons are nearby or in a short way distance to make maintenance or in the annual way. For that, it's necessary to have some trained persons nearby if you want to implement and bring the CHP units into the field, into the market. And for that, it's helpful to have some trained persons that could individually make the maintenance for the units that are in the field. And for that, we are try to give assistance, even with electronic manuals, maybe also later or in following projects with persons inside Next Energy.
Perfect. Thank you very much. Warm applause for you.
Thank you.
Thank you.